Hi everybody, welcome. Very sorry for delaying this. I uploaded a new assignment for recursion. The next two assignments will probably combine a few modules, but this assignment I don't think will be too difficult if you just review some of the videos. And we're just kind of shifting from what we're doing in the PowerPoint. So if you download the zip file, you will get three documents here. Two of them are PI files, and one of them is the Word document. You could drag them to your desktop in whatever editor you want to use. The assignment file essentially just gives you a rundown of what is due. I have this due March 3rd. I know there has been a lot of posting it, so if you need more time, just let me know. But I don't think this should take too long for you to do. But just go ahead and communicate with me if you need more time. Going through this, I essentially made this assignment to have two parts. The first part is basic iterative functions and recursive functions. So there will be 4 questions for you to do. And then the next part will be iterative to recursive as well, where you have these changes here. Okay. Um, each of these have an example output of what you'll have, and there's some scoring down here you could look at. But really, just look at the output of the images to check what you're actually doing, and to make sure that the functions are working properly. Okay, so again, after this, you should kind of get a good idea how recursion actually works, how we can implement it on these different types of elements. And what I'm going to do is just open up the first file that has the A2 functions. So there's quite a few comments in here. So you'll notice here that you have your first two questions are to change it from iterative and recursive. So essentially what you could do is just make an iterative factorial. An example up here is that if I type in something like iterative factorial 5, what I should get out is 120, okay? And again, when you're working through these, you could just check back into your code or your assignment to look at the outputs that you're getting. And then what's handy is that now you can kind of do the recursive version and just remember your base cases and everything. Fibonacci sequence, again, is the one that's the 1 plus 1 plus 1 plus 2. So it's n minus 1 plus n minus 2. There's a calculator here to check on different versions of it as well. But it's a pretty common recursive sequence. So you could just go ahead and double check it there. But you can see here for Fibonacci, if I put in an 8, I get a 21. If I put in a 15, 6, 10, and so forth. So you can see here in the recursive version of this, there might actually be 2 base cases to check for. So just make sure you have that. Recursive factorial LST or list includes, it's essentially the same as your first one, but instead of iterating through a factorial number, you're going to be doing it through a list. So as a reminder with list and how they can actually work with recursion is essentially if I have a list that, let's just say I have 5 elements like this guy. So if I type in 0, my first element, I have my 1. And if I want to get usually to the remainder of the guys there, I can use this little kind of shorthand code called the colon operator. And what I could do is type in my index and then put my colon in there. Okay. So essentially, when we were working on regular numbers like 5 with the addition, what we did was do something like this. Something like that, essentially. Sorry, so like 5 plus 4 plus 3 plus 2. So we kept reducing ourselves into the version. The way that you can work with lists is to use lists of 0 to get your first element, and then kind of do something like plus a rect call on list of 1 to the end. I know I didn't go into too much detail in the first video about this, but this is just one way that you can kind of use recursion with your list here, right? So if I do return lists of 0 with the remainder of the guy, that's one way you can approach it, okay? So essentially the factorial is going to operate the same way as your first guy, but you're just going to want to make it work with a list element instead of the other one. String reversal is similar. I have more information on it too, but just think of string as a list of characters. And for this guy, when you type in hello, it should say, oh, I'm not going to be able to pronounce these, but essentially reverses your string, and it keeps the case sensitivity as well. So you don't need to worry about the cases there, but you can see here that this is just some testing, so whatever you'd like to do. So I don't think these should be too difficult, but if again, if you need more time, let me know. The binary search is the next guy here. And this looks like a lot at once, but essentially, binary search is in the book, and you can probably find implementations of it kind of easily. But what I want everyone to do here is just simply implement their version of iterative binary search, so I binary search, and then kind of keep the same flow that I have here with data and target. And then you can implement an R binary search, which includes a data, target, and a low index and a high index. So remember from our lecture, we created middle, or the MID, using these guys here. So middle is going to usually be created inside of your else statement, in this scenario too, inside of your while. But again, you're going to do some recursive calls here. I'd reference the book for some implementation help if you're very stuck in our binary search, or always feel free to shoot out an email as well. And again, I don't think if you need help looking at the implementations, that's fine. I just want to make sure that you can get experience using binary search with iterative and recursive versions. The second part of this code here, all of this here is just testing that's similar to what you see on the code right here. So you can see here I do I binary search, and then you can pretty much use the same variables that I used just to make sure that's the same way. Um, this data element 21 found at index 7 is something I put in for myself just to make sure you know that it's correct. But you can implement this if you'd like. If you just want to return true or false, that's fine. I'm not too picky about it. Just make sure that you kind of understand where we're finding it. Again, what we're looking for is we're looking at a sorted list. These are all sorted lists, and we're trying to see what index the element that we're looking for is at inside of that list. So you can see your data element 21 is at index 7. The very last thing that I would like you to do in either a TXT file or actually just in a comment down here, you can just keep typing here, is to just briefly kind of look at and answer a few questions about this. Which implementation do you find easier to understand between these two? And why do you find them easier to understand? What do you think about running times here? And remember, we talked about activation records. And essentially, if you don't need to do like crazy math, I'm not trying to ask for like mathematical proofs here, but in your own words, can you kind of explain what you think the time complexity, remember the big O time complexity, is for these two guys, and what you also think the space complexity is for these two guys? Okay. So again, recursion is usually hounded into us a bit earlier, but again, it might not always be effective. So just kind of explain that as well. Great. So I know this is closer to the deadline of March 3rd. If you need more time, just let me know. But go ahead at it, and then feel free to communicate with any questions. Thank you.